Yeah. I'm just gonna go. Yeah. All right. So multiply the polynomials using the FOIL method. So that calls on first multiplying a times c plus a times d plus b times c plus b times d, right? Usually these two guys are going to be like terms, and then you're going to combine them in the end. All right, this is just another way of like kind of proving the FOIL method in a sense. So if we do that with the real variables and numbers that we have in this problem, we're going to do negative x times negative 4x plus negative 6x times negative 6 plus negative 6 times negative 4x plus negative 6 times negative 6. Right? And if we do that, negative x times negative 4x, that's 4x squared. Negative x times negative negative 6, that's plus 6x. Negative 6 times negative 4x, that's plus 24x. And a negative 6 times negative 6, that's a plus 36. That's a bad plus sign. Alright, that's even worse. Okay, let's just keep on going. Alright, so we have the two like terms of 6x plus 24x, so we then combine them to have the final equation of 4x squared plus 30x plus 36. And if you wanted to be fancy with it, what we have in common between all these three terms is a 2. So if we wanted to simplify it, we just take out a 2 from both of them, from all of the terms, sorry, and we have a 2 times a 2x squared plus 15x plus 18. All right, sometimes the questions on, let's say, your quizzes or exams call for something to be factored out, and in this case, if this question wanted to ask that, to have it factored out or something, then we just take that 2 out and have the rest of the equation looking something like this. All right, so everybody's fine on that question. Hopefully. All right, I'm just gonna move on to number 2, factoring polynomials. Whoa, I know some of you guys have trouble with this, right? So you have you don't have a 1 in front of that x squared, and it makes things difficult, right? You see it and you're like, oh no, not this. So I'm gonna help you with that. So one way of factoring this polynomial out is called the AC method. AC method. All right. That first step, step 1, is going to be multiplying A times C. In this case, A is 5 and C is 16. All right. So if we do that, it's going to be 16 times 5, which is equal to 80. Okay. So then step 2 is finding a factor of 80 that adds up to 24. So we look at the factors of 80, we have 1 and 80. We have 2 and 40. This might take a while. 4 and 20. Oh, 4 and 20. That adds up to 24, so we will use that in the case of factoring our polynomial out. So step 2 is finding the factors of our AC, which adds up to 24. The display is only in the right-hand corner. Is there any way to fix this? Is it like that for anybody else? No. You can maximize the screen. Try clicking on the display. You can maximize the screen. Try clicking on the display and then fit to window. Wow, you guys are smart. Jeez. Oh my. Sean, you have smart people in this chat right now, so I think they'll help you find a way. I'm not really the Skype guy, to be honest. He tried that several times. Oh no. Maybe zoom in? I don't know. Click actual size. Brandon Rudabina with the clutch move. Let's see. Click actual size, maybe. Yep, tried that too. Oh, jeez. Sorry to interrupt you guys. No, it's no problem. Cause we're recording this right now, so if like nothing's really showing up for you, you're gonna have the recording for you, and you'll see it in a full like max screen. So you could watch it again if you want to, or you could just stay here and like listen like to my words, I'm guessing. So I don't know really what to tell you. Maybe some other computer science major in here maybe will help you with that. Okay, great, thank you. How can I view the recording? You're gonna be sent an email after this, hopefully. And it's gonna like tell you like what to do. It's gonna be put on YouTube, so yeah. Alright, so you guys type in the chat while I keep on going. So step 2, we have what adds up to 24 right here. So 4 and 20. I'm just putting it in like the inside the parentheses to make things neater. Alright, so then step 3 is splitting up this polynomial to make it easier for us to factor by grouping. And no problem, Sean. So we have 5x squared plus 4x, all right, plus 20x plus 16, all right? Now, next step is going to be step 4. Sorry, I have terrible handwriting. Gonna be grouping these first two and these last two terms. So we have 5x squared plus 4x, boom, boom, plus 20x plus 16. Can you put the 20 first? Let's see. I'm gonna go through this with putting the 4 first, and then I'm gonna do it the other way. All right, so step 5 then is factoring out what the two terms here have in common. So these guys have an x in common, so we're going to take out an x, and we have a 5x plus 4 plus what we have in common of 20x and 16 is a 4. So if we take out a 4, it's going to be 4 times 5x plus 4. All right. So if we know factoring by grouping, we can say if these factors are the same, we can take the combination of their coefficients. So this guy x and this guy 4, and combining them together to then finally have the factors x plus 4 and 5x plus 4 as our final answer. Step 6. Right? So then I'm saying, how do you know which x to put first? Oh, okay. Hold on. All right. So let's try it the other way. So if we have 5x squared plus 20x, let's just say that, plus 4x plus 16. Right? So then if we do the same exact steps as the other way, what's the same thing between here and here? We have a 5x and an x plus 4. Ooh. Uh-oh. Something nice is going to happen. Math is beautiful. Same thing between 4x and 16 is a 4. Take a 4 out. It's going to be x plus 4. Oh. The same thing here is the same thing here. And x plus 4. So we could take their coefficients, a 5x and a 4, combine them to create a factor, and we have a 5x plus 4 times an x plus 4. So to answer your question, Jonah, it does not matter what x comes first. It will give you the same exact answer. All right? Math is fun. Math is great. All right. So then if everybody's good with that and everything, I will move on to the next question. All right. So perform the indicated operation on this monstrosity of a division. All right, so, man, you look at this, you're done with life, right? You have 4 different factors. It's too much, way too much, but let's make it simpler. So we could rewrite this. That's 7x over x squared minus 25 over a 9x minus 27 over a 7x plus 35. We may rewrite that as a multiplication rather than a division. So this can be rewritten into 7x over x squared minus 25 times, I'm going to write a little x for times, 7x plus 35 over 9x minus 27. Remember, keep, change, flip, little method. All right, change this division into a multiplication, and that's what we did here, and then flip the denominator to have what we have here. All right, so one other thing that's nice about this is that we can factor out things from 3 out of the 4 terms. All right, this 7x stays the same because you can't really factor out anything. I mean, a 7 or an x, but you're just being redundant at that point. But this last guy, I mean, the denominator is a difference of squares. All right, so the factors of this are actually going to be x minus 5 times an x plus 5. All right? Now we have that multiplication sign in the middle, and the 7x plus 35 can be factored out since both of them have a factor of 7. So take a 7 out, and we have 7 times an x plus 5. All right. So now a 9x minus 27, we could factor out a 9 from both of them. So now we have a 9 times an x minus 3. All right. So something nice happens when you're multiplying. this factor cancels out from this factor, and one's on the numerator and one's on the denominator. So we could cancel these guys out and now multiply across from the denominator and the numerator and the denominator to have a final answer of a 7x times 7, which is a 49x, and a 9 times x minus 3 times x minus 5. We just combine those to have a 9 times x minus 3 times x minus 5. You don't worry about factoring, foiling, right? Example 1 asks for foiling. Don't worry about that for here, right? They just wanted you to perform the indicated operation, right? And that is our final answer. Okay, so does everybody get that? Everybody's good, great, homely, comfortable. If yes, then I will move on to the next question. Okay, perform the indicated operation. No way, not another one of these. There's no way, but there is a way. So we have a 9 minus x plus 1 over x over 7 plus x minus 1 over x minus 1 over x plus 1. So you look at this and you're saying, what do I do first? That answer is just splitting these guys up from numerator, by numerator and denominator. All right. So working with these, we have a 9 minus x plus 1 over x. If we want to perform the indicated operation, the first thing to notice is that these guys do not have the same denominator. All right, this 9 has a denominator of 1, and this x plus 1 over x has a denominator of x. All right, and if we want to have the same denominator for both of these, what do we have to do to this side to make it look something like this? That answer is multiplying an x over x on both the top and bottom to get it looking like something like this. All right, so if we do that, we're going to have a 9x over x minus an x plus 1 over x. All right, so one thing that students don't do is remembering that there is a parentheses here. All right, it's a slight and subtle parentheses, okay, because this minus sign is going to have to distribute into both this x and that 1. All right, so now if we have that, now we can combine the numerators, all right, since they both have the same denominator, to make it look something like 9 minus x plus 1 in the parentheses all over x, right? Now we distribute that negative inside, so now we're going to have what just happened. Okay, all right, back to normal. To have a 9x minus an x and a minus a 1 over x, right? Combine like terms, 9x minus x is equal to 8x, and it's going to be 8x minus 1 over x, all right? And that is the numerator, right? Working step by step. The denominator now, I'm going to do it on this side. We have a 7 plus x minus 1 over x plus 1. All right, same exact thing as we did on this side. This 7 has a denominator of 1, and to make it look like it has a denominator of x plus 1, or to make it so it has a denominator of x plus 1, we multiply the top and bottom by x plus 1. All right, if we do that, it's going to be something like 7 times x plus 1 over x plus 1 plus an x minus 1 over an x plus 1. All right, so let's distribute that 7 inside, to have a 7x plus 7 plus x minus 1. All right, and now we can have it all over the same denominator of x plus 1. All right, and then finally, combine like terms, 7x plus x is equal to 8x plus 7 and a minus 1. That's plus 6 all over x plus 1. All right, so now that's our indicated denominator. So now, oh my, that's a bad circle. So now if we combine these as numerator and denominator, we're going to have something like 8x minus 1 over x over 8x plus 6 over x plus 1, right? And the same thing as the last problem. Remember what we did here. To perform the indicated operation, which in this case is division, we keep change flip to make it a multiplication. So it's going to be 8x minus 1 over x times x plus 1 over an 8x plus 6, right? Now multiply through and through from the denominator, the numerator and the denominator. I don't know why I keep on saying the denominator first, but yeah, and then we will have 8x minus 1 times an x plus 1 times an x plus 8x plus 6. And if you wanted to be extra pretentious about it, take out a 2 from the denominator from an 8x plus 6 to have 8x minus 1 times x plus 1 times a 2x times 4x plus 3. And that is our lovely highbrow answer. But they will also take this. All right, so everybody's on board with this. Everybody's good, everybody's great. Hopefully nobody's really typing in the chat. So I guess I will move on from here. Oh, we have a typer. A Jonah. I'm saying, how do you do? Oh wait, that's the last. Never mind. That's embarrassing. So we will just move on to the next question. 9y squared minus y plus 4. So finding the real solutions, right? Finding the real solutions just means that you set your polynomial equal to 0, and then factoring out by whichever method you want. All right, and then setting those individual factors equal to 0. Okay, so you look at this problem and you're like, I have the AC method under my method of tricks now, so let's try that. Right, so A is equal to 9, and B is equal to, C is equal to 4. So if we do that, step 1, remember, is A times C. A times C is equal to 36. All right. So now we want to find the factors of 36 that will add up to negative y, or negative 1, because there's an unspecified 1 as a coefficient. All right, so we look at the factors of 36 and we have 1 and 36, 2 and 18, 3 and 12, 4 and 9, and 6 times 6. Do any of those really add up to -1? You think, oh, maybe that's 6 times 6? And nope, none of them really do. So you double check and see if this equation even has a real solution. And to check that, we use what's called the discriminant. All right, everybody should know this for their test because other questions coming up will ask you this. So the discriminant is equal to b squared minus 4ac, right? Where a is equal to 9, b is equal to now that -1, and c is equal to 4, all right? That's the square root. All right? And now plugging all those numbers in, we're going to have a -1 squared minus 4 times 9 times 4, all under the square root. All right, one more step. That's going to give us 1 minus 16 times 9, or 36 times 4. That's 144. Simplified down, that's going to give us -143. We have ran into a problem. Remember, guys, you do not want to have a negative number under the square root. All right, that calls for a complex number solution, and you guys are not working with that yet. All right, so, and also the question asks for real solutions, okay, not complex, not anything like that. So in this case, this polynomial will not have any real solutions, no real solutions. All right, we tried one method of doing the AC method and stuff like that, and then finding if this polynomial even has a real solution. All right, and we did that by using the discriminant. Okay, so let's say if this was a square root of 143 positive instead of negative, then in fact there would be a real solution, and then to further execute this we would have to use the quadratic formula, all right, which uses the discriminant in it. Okay, so everybody's good on that one, hopefully. Boom, 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 boom. Moving on to the next one. All right. So whoa, weird how that's the next question. That's crazy. Use the discriminant to determine whether the quadratic equation has two unequal solutions, a repeated solution, or no real solution. All right. Oh, we have a typer. Kendrick. You're there. You're typing. But what are you typing? Let's see. This might be a very long message, maybe, or he just, okay, all right. No message received. So we're just gonna move on. So we have this question. Typing again. Okay. So have you gone over any questions that ask about equations used in calculus? Whoa. No, I have not gone over that, but we will, I'll give like some time at the end where you could ask any questions you guys want. So if you stick with me for now, I'll get to your questions about equations used in calculus. What do those look like, by the way? Equations used in calculus. Just give me an example for now, and then I'll like think about it as we like move along with the review. When does the session technically end? Technically, I could extend it till 9 if you guys want to. I'll be here till 9. But if everybody's like gone before then, I'll just like end it before then. But if you guys keep on having questions, like I'll be here. So yeah. All right. So if everybody's good, I'll keep on going with this one. I'll go a little bit faster too, just so you guys have question like time in the end as well. All right, so I'm just gonna wait for Jonah's message. Hopefully he types really quickly. Okay, I'll just move on. So we have use the discriminant to determine whether the quadratic equation has two unequal solutions, a repeated solution, or no solution. Example would be 5 times 2x plus 1 plus 5. Okay. All right. I'll keep that. I'll keep that in mind, Jonah. All right. And also Kendrick for like the questions at the end. All right, guys? So moving on to this question, we have 16x squared plus 41x plus 25. All right. So what's the discriminant? We have b squared minus 4ac square root. All right. So a is equal to 16, b is equal to 41, c is equal to 25. Let's all implement that into the equation. We're going to get 41 squared minus 4 times 16 times 25. All right. And if we all use our mental calculators, 41 squared is going to be equal to 1681 minus 1600. All right. You guys are allowed calculators on the test, I'm assuming, so you guys should be fine just multiplying these through. So then square root of 1681 minus 1600, that's just square root of 81, which is equal to, ooh, is it 9 or something else? It's going to be plus or minus 9. Remember, guys, aka the square root method. All right, square rooting a number is going to give you two real solutions, both a plus solution, a positive solution, and a negative solution. All right, so we have a plus or minus 9. Okay, so which one is it going to be? Two unequal solutions, a repeated real solution, or no real solution? So our solutions are plus 9 and a negative 9. Are they equal? No. So the only one that would make sense are two unequal solutions. All right. So this question just asks for using the discriminant to determine whether the quadratic has however many solutions, right? And just implement this formula and you should be fine. All right, find the real solutions by factoring. Okay, so finding the real solutions, once again, is making your polynomial or anything like that equal to 0. And then solving by, they even say for us this time, factoring. So we have a 2x cubed minus 3x squared equal to 0. All right. One thing that they have in common is that x squared. So if we take an x squared out of this one, it's going to be left with just a 2x, and this one just a minus 3. Okay? And that's all equal to 0. All right. Now finding the real solutions is setting both this x squared term and this 2x minus 3 term equal to 0. So let's do that on the side. x squared is equal to 0, and 2x minus 3 is equal to 0. Okay? Let's solve this one first. X squared is equal to 0. What do? We square root both sides. That's going to be x is equal to, ooh, little existential crisis here. Remember what I told you about when you're square rooting a constant number, or just any number? You're going to get two real solutions, right? A plus or minus solution. But in this case, since it's 0, there's no such thing as a plus or a minus 0. It's just 0. So this term is just x equals 0. And for this one, just solve for x. So 2x is equal to 3. And then an x is equal to 3 halves. All right, guys? So that was really it for that one. We have solved the inequality 7 minus 3x is less than or equal to negative 11. Whoa. Okay. All right. So first step is making it so your variables are on one side and a constant number, hopefully a constant number, is on the other side. All right? So if we do that, we solve for x. So we subtract a negative 7 from both sides. We're going to get negative 3x is less than or equal to negative 18. All right? So now if we want to solve for x, we just divide both sides by negative 3. And then it'll be x is, ooh, ran into a problem here. Remember, guys, when we divide by a negative number in terms of an inequality, the inequality changes its direction or sign from less than to now greater than or equal to. Right? That equal to stays there. Right? Never goes away. But in technology right now, it went away. Wow, it keeps on going away. That's annoying. So then we have negative 18. No, it doesn't change if you divide by a positive, Jonah. So we have negative 18 divided by negative 3, and that turns into just a 6. So our final answer should be x is greater than or equal to 6. All right? Then our solution set, which I know some of you guys are like, some of the questions ask for, if x is greater than or equal to 6, that means that x can be any number greater than 6 and equal to 6. So it's gonna, why is it deleting? It's gonna look something like a bracket with 6. Remember, a bracket is used for when it's including, comma, infinity, parentheses. It's going all the way to infinity because remember, x can be any single number you could think of, a billion, a trillion, quadrillion, septillion, anything. All right? But it could be anything after 6, and it could also be 6. And you put a parentheses with that infinity because infinity is not a real number, guys. Infinity is an idea, it's a thought, all right? So if you guys go on with your mathematical careers or whatever after this, just don't think of infinity as a number. Think of it as just an idea of really large numbers that we don't even know about, right? So that's just a little trip down math road, I guess. I don't know, that was a corny joke. So we're done with this one. And then we have, oh, actually, to finish this off, let me just do a number line for this one, because I know some of the questions ask for it. So if we draw that, we have 6. All right, So we will draw a shaded in circle at 6, shaded in because it's included, right? And then hopefully that circle stays there. And then we will shade in everything after 6, right? Because it's from 6 to infinity. Alright guys, so next question. Find the distance between the given points. Alright, so we have that P1 is equal to 1, comma 4. P2 is equal to negative 3, 5. Alright, so we have a distance formula. Very, very important. We have that D, or distance in two-dimensional terms, is the square root of x2 minus x1 squared plus y2 minus y1 squared, right? In this case, x1 is equal to x1, 4 is equal to y1, negative 3 is x2, and 5 is y2, all right? So now, just plugging it all into the formula, we have that it equals to x2 negative 3 minus x1, that's a minus 1 squared, plus y2, that's 5, minus 4 squared. That's equal to the square root of negative 4 squared plus 1 squared. Boom, boom, boom. Negative 4 squared is 16, plus 1 is 1, and then our final answer is just 17. All right, so remember this formula like the back of your palm, hand, whatever that idiom says. All right, square root of x2 minus x1 squared plus y2 minus y1 squared. And if you want to get really mathy with it, we could use triangles to kind of prove that this is true, right? Just using Pythagorean theorem, right? But I don't think your teacher or anything on the test calls for that, right? So if we're good on that, then we will move on to example 10. All right, so determine whether the given points are on the graph of the equation y squared is equal to x squared plus 1. This one's really nice. It seems like it's confusing, but you guys are going to be like, wow, finally, an easy question. So, the only thing that you need to do, if it asks determine whether the given points are on the graph of the equation y squared is equal to x squared plus 1, all you need to do is plug in what your x is and what your y is into the equation, and if it holds true, then it is on the graph of the equation, right? So if we do that, y squared is just 1 squared is equal to 0 squared plus 1. 1 squared is 1, 0 squared is 0, 1. That turns into 1 is equal to 1, so that's true. And then that means that this like coordinate is on the graph of the equation, right? So let's move on to the other one and say 1 comma 0. This is your x, this is your y, right? Y is equal to 0, so we have 0 squared is equal to x squared, which is 1 squared plus 1. That turns into 0 is equal to 2. Does that even make sense? Any sense? 0 is equal to 2? No, so that is not on the graph of the equation. Right, C, negative 1, 0. This is your x, this is your y. All right, so if we do that, it's going to be 0 squared is equal to negative 1 squared plus 1. And that turns into 0 is equal to negative 1 squared. Be careful with this. Negative 1 squared, when you square it, it turns into 1. So that's a 1 plus 1. That turns into 0 is equal to 2, and that's the same exact problem that we had here. 0 does not equal 2, so then That is false, so that coordinate is not on the graph of the equation, right? So are you guys good on this question? Yes, no, maybe so, yes. All right, guess I'll just move on. So find the x-intercepts of the equation 5x squared plus 64y is equal to 320. All right, so first step of finding the x-intercepts of any equation is making your y equal to 0, but we have to have the coefficient in front of the y equal to at 1, all right? So to do that, we have to rearrange this guy to have y on one side and x on the other side. So right now we have 5x squared plus 64y is equal to 320, right? So let's move this negative, gotta give away the answer. Let's move this 5x squared to the other side to have 64y is equal to negative 5x squared plus 320. Right? So if we want to have that y to have a coefficient of 1, we have to divide everything by 64 over 64. All right. So if we do that, that's going to be y is equal to negative 5 over 64 plus this, oh, sorry, that x squared is missing. What is nice about calculators is that you do not have to do this in your head. So you will know that 320 plus over 64, sorry, is going to be equal to a number 5. All right. So after this, actually, for this specific question, you don't want to do it yet. You don't want to simplify this 320 over 64 yet. We just keep it as 320 over 64. All right. This will come in handy later. So the next thing is setting that y equal to 0. So now we have 0 is equal to negative 5 x squared over 64 plus 320 over 64. All right, guys. So then remember, when y is equal to 0, that means we could do all our factoring techniques. All right. So one thing that we could do is, what is the same between this guy and this guy? They both have a 1 over 64 as a factor, right? So then, if we also want to make it even easier on ourselves, we could take that negative 1 over 64 out, since that there's a negative in front of that 5x squared, to make it as 1 over 64 now times of 5x squared. Since we took a negative out of both this and this positive turns into negative. All right. So now we have 0 is equal to negative 1 over 64 times 5x squared minus 320. All right. So next step in this is doing what? We can multiply both sides by the reciprocal of negative 1 over 64. So a positive, never mind. A negative 64 times 0 is equal to negative 64 times a negative 1 over 64 because you want to get this coefficient to be equal to 1 times a 5x squared minus 320. So these cancel. Anything times 0 is 0, so now you're just left with 0 is equal to 5x squared minus 320. Alright, so now we can factor it even more. What's the same between 5x squared and 320? If we take out a 5 out of both of these guys, and we have x squared minus, and what you're left with, again, the miracles of calculators. 320 divided by 5 is 64. Is equal to 0. Again, what we did here, divide by 5 on both sides, like similar to what we did here, where we multiplied times the reciprocal. We will divide by 5 now to have 0 is equal to x squared minus 64. Alright, I'm going to move this over here now. Alright, so 0 is equal to x squared minus 64. We could move that 64 on the other side to have 64 is equal to x squared. And now we just square root both sides to have plus or minus 8. Don't forget, guys, plus or minus 8 is equal to x. Alright, and now officially our x-intercepts are going to be what? They're going to be 8, comma, remember x-intercepts are when y is equal to 0. That's what we did on this. So our y point is going to be 0, comma, negative 8, comma, 0. And those are our x-intercepts of the equation 5x squared plus 64y is equal to 320. Right? Kind of have a hefty problem, alright? We had to move that 5x squared plus 64y, rearrange it so that y was equal to another equation. Y was like on its own. What did you do with the negative 64 is equal to negative 64 thing? On this side, over here. I did that so this coefficient right here, this negative 1 over 64, can be equal to a 1, alright? So I multiplied negative 64 times negative 1 over 64. That's just going to be negative 64 over negative 64, those cancel, that cancels, and that's going to be equal to 1. No, the thing below, over here, right here, negative 64 times 0. Yep, that's what I was saying. I was multiplying both sides by the reciprocal of negative 1 over 64, and that is negative 64. So I multiplied it on both this side, the left side, and the right side, and that was because I wanted this coefficient in front of that 5x squared minus 320 to be equal to 1, right? And whenever you multiply times the reciprocal of something, you will get a 1 like that, right? Good, great. So that way it doesn't get included with the final answer. Yes, exactly. Yeah, because if you left that negative 1 over 64 in like this step right here, it's going to be like, it's just going to make your life more difficult with like trying to factor out stuff, and you don't want to make your life difficult when you're doing a test with however many questions and you're timed. All right, so this is just also just a time saver as well. All right, so If we know that and we get this question, I'm just gonna move on to the next one. All right. Find the real solutions of the following equation. All right. Same things that we have been doing. All right. If we want to find the real solutions of the following equation, we have to make it so that one side is equal to 0. All right. So right now we have that 3 plus 6x minus 2 is equal to x. All right. Step by step, we're going to create it so that one side is equal to 0. In this case, the easiest way of doing this is by first subtracting 3 on both sides. So we have square root of 6x minus 2 is equal to x minus 3. All right? If we want to get rid of that square root, we square both sides. That turns into 6x minus 2 is equal to now x minus 3 times another x minus 3. Right? Now we have to multiply this though using the FOIL method. So if we do that, we have 6x minus 2 is equal to x squared minus 3x plus a 9. So now we have 6x minus 2 is equal to x squared minus 6x plus a 9. Remember, our goal is to have this or any side equal to 0. So let's make it easier on ourselves. Make this side equal to 0. So we have to subtract a negative 6x on both sides and add a 2 on both sides. So if we do that, it's going to be negative 6x minus negative 6, that's a negative 12x, a plus 2 times plus a 2, a plus 9 plus a 2, it's going to be plus 11, all right? And that's equal to 0. So if we have that now, we have this equation, we can make it easier on ourselves by finding the real solutions to just factor, all right? And let's use the AC method, right? So we have x squared minus 12x plus 11. I'm going to move it over here. First step, AC, 1 times 11 is equal to 11. All right. So now we want to have the factors that add or subtract to negative 12. So we have 1 times 11. It's lovely because it's a prime number. So these are the only factors of 1 and 11. All right. So if we have that, we want one of them, or actually, sorry, both of them to be negative because we want to add them up to give us that negative 12. All right. So if we follow the AC method, our next step is having x squared minus a 1x plus an 11x plus 11, right? What's the same between x squared minus x? Something to take out is just an x. Let's do that. And we're left with an x minus 1 plus the same between negative 11 and an 11 is what? A negative 11. So if we do that, it's going to be plus a negative 11 times an x minus 1. So now they have the same factor of x minus 1. So now we could factor by grouping. So we take the coefficients, an x and a negative 11 to have an x minus 11 times now an x minus 1. And remember guys, this is still equal to 0. So we set both of those equal to 0. And now we make them individually equal to 0 to have an x minus 11 is equal to 0. And x minus 1 is equal to 0. And finally solve for x in both of these equations to have an x is equal to 11 and an x is equal to 1. Right, so that was that for this problem. All right, first step was just we want one side to be equal to 0 if we're trying to find a real solution. All right, it's kind of like finding an x-intercept. All right, you set your y equal to 0 and then you solve for x using factoring by whatever method you want. All right, we use the AC method in this case. Okay, and then it got us our answer of both 11 and 1. All right, so next step, solve the inequality. We have -2, oops. We have -2 is less than or equal to 2x plus 2, which is less than or equal to 6, right? So we want that 2 to be by itself. I mean, that x to be by itself. So we have to use some operations, addition, subtraction, maybe division or multiplication to have that x by itself. But what you do to one side, let's say the right side of 6, you have to do the exact same thing to the other side of -2, right? So let's say the first step in this one is to divide, or let's make it easier on ourselves, is to subtract everything by -2. So if we do that, we have a -2 on that side and a -2 on this side. So a -2 minus a 2 is going to be equal to -4, which is less than or equal to a 2x. We subtracted a -2, so that 2 is gone. Is less than or equal to a 6 minus 2, which is a 4. Okay, guys? Next step is dividing everything by 2, because again, we want that x to be by itself. So if we divide it by 2, we're going to have -2. It's less than or equal to x, which is less than or equal to 2. Right? The signs don't change direction because we're not dividing by a negative. Okay? The signs only change direction if we're dividing by a negative. Okay, guys? Please remember that. It's a little mistake that even I've made like countless times on like tests or quizzes. I just didn't realize that I was dividing by a negative and then I got the entire question wrong, which sucks a lot. So hopefully you guys don't make the same mistake. Just keep on practicing and it'll become second nature. Right. So that is our final answer of the inequality. All right. To show this though in a number line, I'm gonna just write this. We have the endpoints -2 and 2, and our x is everywhere in between that -2 and 2, right? But it is also including -2 and 2, right? So these circles are going to be filled in at the endpoints -2 and 2. I like how this dot went away, but this one didn't. That's so weird. And now we're just gonna shade everything in between. Right? Remember, if it's included, it will have an equal sign. And if it's included, this dot right here will be shaded in. Alright, guys? So then that's it for that problem. So for this one, test for symmetry. Alright. So rules. Testing for symmetry. If we test about the x-axis, we want to make the y squared equal to x plus 9. We want to have that y equal to a negative y. Make y negative. And if when we plug in a negative y for y, and if it gives us the same exact equation, that means that symmetry, it's symmetrical about the x-axis, all right? Let's say we test about the y-axis. Same thing, but this time we make x negative. So that means if we plug in a negative x for x, and if we get the same exact equation of y squared is equal to x plus 9, that means it's symmetrical about the y-axis. Okay? And now test about the origin. All right? Same thing as doing it for the y-axis. Make x negative. But one more trick, well, I mean, not trick, but little thing you have to keep in mind, that when you make x negative, if it turns into the negative of this entire equation, that means that it is symmetrical about the origin. So let's say if you make x negative here, and this whole equation becomes negative y squared is equal to negative x minus 9. Let's just say that happens. If we plug in a negative x for x, that means that it's symmetrical about the origin. Okay? So now we're going to test it for this equation, all these three cases. So let's test about the x-axis. Let's make y negative. So we have negative y squared is equal to x plus 9. That just becomes a negative y squared, y times negative y, that's going to become y squared is equal to x plus 9. Is that the same exact equation that we have here? Yes, so this is symmetrical about the x-axis. All right, so let's test the y-axis. Let's make x negative, so it's going to be y squared is equal to negative x plus 9. That turns into y squared is equal to negative x plus 9. And is that the same exact equation that we have here? No, because that x is not negative here. All right, so that means it is not symmetrical about the y-axis. All right. So now let's test the origin. Same thing as testing about the x-axis, except that extra step. So same thing as making, like, testing for if it's symmetrical about the y-axis. All right, so we have that y squared is equal to negative x plus 9. That turns into, again, y squared is equal to negative x plus 9. All right. Is that the same as what we had here, which was negative y squared is equal to negative x minus 9? Is that the same as that? No. So this is not symmetrical about the origin, right? Because if it was, this equation would turn out to be that negative y squared is equal to negative x minus 9, right? So remember these rules, all right? And remember that extra step for testing about the origin. Okay, guys? So I'm going to move on to the next one, the final one, and then question time. All right, so we have find the midpoint of the line segment joining the points P1 and P2. Basically, the same question type as finding the distance. Just remember a formula, should be fine. So the formula for midpoint is x1 plus x2 over 2, comma, y1 plus y2 over 2. All right, 2 is your x1, -6 is your y1, 8 is your x1, 6 is your, x2, y is your y2, right? Kind of jumbled in there, but you guys know. So if we plug all those in, we're going to have that it equals x1 is 2, y2, x2 is 8, so it's 2 plus 8 over 2, comma, y1 is -6, so y2 is plus 6, all over 2. That's equal to 10 over 2, comma, 0 over 2. And that simplifies to 5, comma, 0. Right, so that is the final answer for that. And yeah, so just remember that formula, x1 plus x2 over 2, comma, y1 plus y2 over 2, and you should be fine. All right, so any more questions that you guys want answered? That calculus question one, I'm gonna go back to it really quick. Yeah. Tell me if I'm writing this right as well. Hold on. An example would be 5 times 2x plus 1 squared. All right, I'm going to create a new slide. All right, I'm just going to write it down. We have that 5 times 2x plus 1 squared plus 5x plus 6 squared times 2 times 2x plus 1 squared. All right, I think that should be it, right? Did I write it correctly? That's a multiplication sign. I'm just gonna write it next. No squared for 5x plus 6? Okay. So it looks something like that, right? Oh, 5x minus 6. Okay, sorry. 5x minus 6. Then that should be the right thing. Right? Hopefully. Times 2, not squared. Oh! Jeez, all these little scribbles. Alright, so that should be right. Hopefully that should be right. That's right, okay. So we have that 5 times 2x plus 1 squared plus 5x minus 6 times 2 times 2x plus 1. And that's what we have, right? Yep. Okay, so don't let it fool you. Wait, there's a times 2 at the end. I did it right here, a times 2. Right over here. Or is there another times 2? There's a 2 here and a 2 here. Dang, that's obnoxious. Right, so first thing is finding what's the same between this term and this term. And also that thing that they say, like, oh, this question's from calculus or whatever, trying to scare you. They're just trying to scare you into thinking this question's harder than it seems. Right? So don't be scared, you'll be fine. Alright, so we have 5 times 2x plus 1 squared plus a 5x minus 6 times 2 times 2x plus 1 squared. Alright, so what's the same between this 2x plus 1 squared term and this 5x minus 6 times 2 times 2x plus 1 squared? They have the same factor of 2x plus 1 and a 2x plus 1. Alright, so if we take that out of both of these, we're going to have a 2x plus 1 times, I'm going to write a little bracket now to signal a different term. So it's going to be 2x plus 1 times 5, and we're only left with 1 2x plus 1. So it's 5 times 2x plus 1 plus that 5x minus 6 stays, plus a 5x minus 6 times a 2 times 2x plus 1 times 2. We took out that 2x plus 1, one factor of it, so that's gone. And now we're left with is that times 2, which is just 4, right? And now all we have to do is combine like terms on the inside, but first we have to distribute on the inside. So we have 2x plus 1 times 5 times 2x plus 1 is 10x. 5 times 1 is plus 5, plus 5x times 4 is a 20x, and a negative 6 times 4 is a negative 24. Right? Last step is combining like terms. So 10x plus 20x is a 30x. Plus 5 minus 24 is a minus 19. Jeez, minus 19. I can't write a 19 to save my life. And that's it. That's your final answer. All right, so all the steps that we took are just combining, or I mean not combining, I'm sorry. Thanks, Jacqueline. My name is not Jacqueline, by the way. My name is Brandon. That's a funny one. All right, that was a good joke. That was a good one. I'll give it to you. But yeah, that was a really good one. I'll give you that. That should be it for this question. All right, so first step is just finding what's the same between this term over here and this term over here. And in any case in these types of problems, you're just trying to find what's the same and what factors are the same between the two sides and taking those out and then combining what you have left, and then that's it. All right, anybody have any more questions?